To lead off, we have Lars Gunther representing Sanket Image.
Hello, everyone. As he said, I'm Lars. I help maintaining Sanket Image, and I want to briefly talk about what we've been up to in the past year. So we've had 2 releases, and one of the exciting things to come out of it is actually also the result of an outreach project, and that is a new transform class. So what can it do? If you see on the side, there's an image of something that is distorted in a barrel distortion. That's a nonlinear distortion, and this transform class can actually help you correct that or transform it, and it's very intuitive. You can, basically you just place points inside the image and then pull those points to places where you actually want them to be, and the rest of the image will follow along. And I'm very excited to have that in Sanket Image now. We've also added a function that's remove objects by distance, and that kind of does what it says. If you have a cluster of pixels, that's an object, you can specify, oh, I want these objects in my image to be spaced at least this distance apart. And you can even specify the priority. Oh, and it's n-dimensional. We've also had a lot of work actually on our morphological functions under the hood, like erosion, dilation, and stuff like that. So you can now better specify how waters are handled, which can help with a lot of edge cases. You might have also noticed a recent upgrade of NumPy 2, so that's also been some work that's went into that, and we are happy that we are now supporting it. And there's more stuff to check out in the release notes, so I encourage everyone to check it out. So what's next? Next, we're still planning the transition to Skimage 2. That's in a new namespace. Basically, you want to get rid of some API decisions. We think we can now do better and more intuitively. We're also in the process of adding type annotations to our library, and we want to do that via turning docstring descriptions, which are describing parameters, into typing stubs in an automated way, because we only want one single source of truth. We're also planning or in the process of adding pyodide to our docs to make them more interactive. And finally, the most exciting thing, we want to do a logo update. And we're actually looking for people who can turn our import name, a skiing mage, into something that might be a cute logo. So if you're artistically inclined, please approach us. We are very happy to get your input. Thank you.
Next up, Matt Haberland for SciPy.
Hey everybody, I'm Matt Haberland. I'm a maintainer for the SciPy and NumPy libraries, and I work at Cal Poly San Luis Obispo. And today I'm going to talk to you about SciPy, not just a conference. The library, we support fundamental algorithms for scientific computing, including linear algebra, interpolation, data structures, statistics, and optimization, many more. Some recent highlights from recent releases. We've got NumPy 2.0 support now. Modernized code. About a year ago in SciPy, we have about 150,000 lines of Fortran 77 code, and we're, thankfully about halfway towards more modern translations of that. That's going to be more maintainable. We have support for other array libraries that is exposed through experimental environment variables. So if you want to try out SciPy with PyTorch or QPy or JAX, then enable SciPy array API equals 1 as an environment variable, and you can try these things out. Note it's experimental, so please let us know what bugs you find. There's also been a lot of improvements towards sparse arrays, trying to transition away from sparse matrices, and most recently support for 1D sparse arrays. And we've re-enabled Apple's Accelerate, BLAS, and LAPACK library support. Oh, it looks like we're cutting off here. But we also have executable examples, the tutorials. So there are some icons that would show that you can look for in the documentation. You can click that and run your code as a notebook and test it out right there in your browser. Oh, yeah, that's what they look like. So some coming attractions. We've got a shared special function library that's under development. And the idea is one library that you can execute with CPU or GPU-based backends. So that could be shared by QPy and JAX, et cetera, so that we don't have lots of separate implementations of these special functions, which are very tricky to get right. There's a new random variable infrastructure that's under development. We're working on making it work as a random variable infrastructure, and so you'll find it more intuitive, faster, more accurate, et cetera. And we have new element-wise functions for doing things like root finding, minimization, quadrature, series summation, and new SciPy.differentiate, which just merged recently. So there's lots of ways of getting involved. Please scan the QR code or talk to me later to find out more. Thanks.
Next, we have Matthew Fiker representing JOS, and Trevor, you're on deck.
Okay, hi. So I'm giving the update today for JOS, the Journal of Open Source Software. And at the 2022 update, we said that the state of JOS is strong, and I'm happy to report that that is still the case, but we're also growing quite rapidly. So in May 2023, we published our 2,000th paper. And we're keeping trucking because basically just a year later, we've published over 500 more, and we're continuing to kind of keep this velocity up. So to make sure that we're able to kind of scale and keep up with all the wonderful papers, submissions that are coming in, we've structured ourselves now so that we have 7 scientific domain tracks that each have one of the associate editor-in-chiefs leading them. And then we also have many different communication and outreach channels for the broader community to stay informed about JOS. The JOS blog is still a really great way to get information, but we now also have JOS Cast, which is the inaugural JOS podcast, and you can get that wherever you get your podcasts. But growing JOS also requires scaling up. That means both in terms of personnel. So we need more editors. So back in 2022, we had 69, and we've grown that out to over 80 now. But we need, for the journal to be functioning and healthy, we need to make sure that this team of volunteers doesn't get burnt out. So we're also currently starting to do rotations of the associate editors-in-chief. And then we're also doing topical editor term limits to try and make sure that everyone is fresh. So consider this a call to action. We want you to join the editorial team for JOS. So if you have questions, please come find us. And in addition to trying to scale up our personnel, we're also trying to scale out our tooling. So this means trying to use machine learning and automation to try and improve and streamline the reviewer selection process, and also trying to make sure that authors have a really clear way to try and prepare their submissions, and also that when the editorial team has plenty of monitoring and validation tools to try and make sure that, that they can keep the journal moving. And since everybody seems to love editorial bot, we want to try and give people more of what they like, so we're trying to make editorial bot even better. Okay, so if you have questions or you want to become a JOS editor, please come and find any of the people here. So Josh, Kyle, Kristen, and myself, we're all part of the editorial team, and we would love to try and talk with you about JOS. So thanks very much. Come talk.
Trevor Manns representing AnyWidget.
Yeah, hi everyone, I'm Trevor. I'm a visualization researcher, and I'm finishing up my PhD at Harvard Medical School this year in the High Dive Lab. And I'm presenting AnyWidget, which is a tool that aims to make creating and authoring custom Jupyter widgets easy. And it does this through web standards. So as Dan mentioned, we're one of the newcomer projects. So this work came out of some of my PhD work in trying to build interactive biomedical visualization applications for some researchers at the medical school. And so AnyWidget is both a specification that's built on top of the modern ECMAScript module standard in the web browser, and then a toolkit for authoring and distributing that through PyPI and reusable widget form. And so AnyWidget defines this specification and also manages cross-platform compatibility in computational notebook environments like Jupyter Notebooks, Jupyter Lab, Google Colab, and VS Code. And then also many different dashboarding frameworks have support for Jupyter widgets as well. So things like Panel, Shiny for Python, and Solera all work with AnyWidgets as well. So some highlights since the year and a half since AnyWidget was released. We now have a community that's on Discord. Come join us. The official Jupyter widget JavaScript cookie cutter, which was sort of the standard way of creating Jupyter widgets, is now deprecated and recommends using AnyWidget. We have a CLI for bootstrapping new projects if you'd like to try out making widgets of your own. And beyond the Jupyter ecosystem, this front-end specification is now being adopted into non-Jupyter environments as well as a sort of platform-native standard. So Marimo, which is a new interactive computational notebook, is building their third-party extension module system around the AnyWidget definition. And Panel, we've been in discussions with the Panel developers about building more tightly integration of the front-end module into AnyWidget as well. And this is our first SciPy presenting. So in this last slide, I just wanted to highlight our documentation now actually has a set of community gallery of projects that are now using AnyWidget and things that you might be able to try out inside of notebooks or anywhere that Jupyter widgets work. And also, I just wanted to highlight there's a couple projects here at SciPy this year that are also using the project. So if you want to chat widgets and anything interactive in Jupyter, come find me. Thanks.
Next, we have Sarah Johnson representing Dask, and Jessica up next.
Hey everyone. So for those who are not familiar with Dask, it is a Python library for parallel and distributed computing. It scales the PyData ecosystem, so tools you're familiar with like NumPy, Pandas, Xarray, scikit-learn, but it's also a general purpose computing framework. It's easy to use and used by a lot of institutions and orgs. So what's new in Dask? So there's been a lot of performance improvements for Dask data frame. That's the API that feels the most similar to Pandas. So the three most impactful changes that I'd like to highlight are enabling PyArrow strings by default. This is a lot more memory efficient data type. Better shuffling, so merges are a lot faster. And the query optimizer, so that automatically rewrites your code to make queries a lot faster and more efficient. And there's also been a lot of work ongoing for Dask arrays. So too eager data loading has been resolved by a task queuing, and then we're still working out better rechunking. We'd love for folks to try it out and give feedback. And then as the latest Dask release last Friday, there has been a query optimizer added in for Dask array as well. So that's highly experimental, but hot off, just released. So all of these changes to Dask data frame have made it a lot faster, so up to 20 times faster, and these are the result of all of these changes layered on top of each other. There's also, it's a lot more robust, and that robustness helps us actually be able to use Dask at a scale that was prohibitively slow before a lot of these improvements. So we've done a number of benchmarks at scale using Coil to deploy Dask on the cloud. And we found that Dask is even faster than Spark at terabyte scale. If you'd like to hear more about this, my colleague James Bourbeau is going to be giving a talk at 2:30 later this afternoon, and he is going to go a lot more into these details. I also wanted to talk a little bit about Dask array. So this is ongoing, and these improvements are largely, as I mentioned before, so we've got too eager data loading is solved by the task queuing that's been implemented. This example here, you're looking at 250 terabytes of the national water model. This was previously really hard to do because of memory errors, and a lot of those have been resolved, and we keep working on making them better. So yeah, Dask there have been a lot of performance improvements, and we hope folks will try things out, give feedback. yeah, thanks to all the users and developers who help make Dask better. Feel free to check out the documentation or find us on GitHub. We have a booth right outside those doors, so come say hi, come talk to us. Thanks.
Jessica Scheik on X-ray.
Hi, everybody. I'm Jessica Scheik. I'm excited to give you a quick update on X-ray on behalf of the X-ray maintainers. And of course, thank all of our various funding sponsors that help a lot of us fund our time to work on X-ray. So for those of you who have maybe not worked with X-ray before, what is X-ray? It's a library, Python library that allows you to work with your data arrays as ND-labeled arrays, data sets, and metadata, put them all together in a really great model for interacting with your data based on labeled axes, so latitude, longitude, if you're like me and you have a background in earth science, but you could also use it for numbering the genomes of the mosquitoes that you're studying as well. So very, very diverse applications. Some new feature highlights. The last year or so, lots of improvements in the performance between X-ray and XAR. An effort called named array, which is trying to isolate what was sort of previously heavily integrated into the X-ray variables module, separating that out into something called a named array, so it provides a much more lightweight, efficient array structure for working with arrays with named dimensions without having it be dependent on pandas. We just released some categorical array support. And then I want to highlight this exciting new feature that is very close to release, which some of you may have worked with this library when it was independent before it was incorporated directly into X-ray. It is called data tree. It is a hierarchical tree of X-ray data sets. So for those of you who are working with HDF files, previously that could be a very repetitive read in each group individually. Data tree does that all for you and is very performant and efficient. Highly recommend that you check it out. Our current roadmap, we're continuing to work towards increasing flexibility, interoperability with all of the other incredible tools in the ecosystem. We recently received funding for an X-ray developer position specifically focused on biomedical research and expanding our usage in the biomedical research community. So if you're interested in that, please feel free to reach out. And then last but not least, as always, we continue to focus on engaging more users, improving our already robust and what I would say is really great documentation to make it even more accessible, particularly to folks who are new to the library. Part of that, you may have noticed, we've updated our logo. We have revamped our website. And if you haven't seen our tutorials, I would encourage you to check them out. And hopefully you'll come check out this great graphic to help you navigate all of those resources better.
Don't look at this and duck out just yet. It's Gil Foresight.
Hello, everyone. I'm Gil. I'm here to give an update on IBIS. IBIS is, as you can see, a 100% portable Python IBIS data frame library. What that means is we're just an interface, so we're not an engine. We let you use all the engines that already exist. So if you've got data in Oracle or in PySpark or wherever else, you can use our interface and then execute your query wherever your data are or sort of with whatever system you want to use. It also takes a lot of inspiration from dbplyr and dplyr. Just to call back to Julia's keynote there, we look to other communities. Big updates, we did a ground-up rewrite of all the compilers and a complete IR redesign. This is the work of a lot of people, but like a huge shout out to Christian Schux, who led this. This ended up in being a net removal of 15,000 lines that doesn't include any tester snapshots, but gave us more functionality across all the backends. API consistency and cleanups. Schema only means one thing in IBIS now, and that is a mapping of column names to data types. And we've eliminated Postgres' horrible abomination of using it to mean 3 different things. That was bad. We have support for streaming databases now, including Flink and Rising Wave, and coming soon Spark Streaming. There's a new Exasol backend. You can use Polar's data frames as inputs and outputs for all operations. So if you've got a Polar's data frame and you want to shove it into Oracle, you can do that now. We have support for Dunder Arrow C-Stream, Dunder Data Frame, fast local geospatial support with DuckDB Spatial. That's thanks to Natty Clementi, who's over there, and is giving a talk tomorrow at 10:45 a.m. in room 315 about that. And I'm giving a talk on IBIS and interfaces Friday at 1:55 in room 316. Ecosystem updates. We redesigned our whole website using Cordo. I swear I wrote these before I saw the keynote. And Cordo Docs, big thanks to Michael Chow, who was working on Cordo Docs to make it work with our requirements at SciPy last year. We've got support in Hamilton, Altera, Plotly, Vega Fusion, and more. You can run IBIS inside Snowpark on Snowflake, which is wild. And they said we were ungovernable, but we do have governance now. So that's a good thing, Project Health. Also forgot to put a note here about it, but we got IBIS working in Pyodide, and thanks to Joe Marshall's work, you have Pyro in Pyodide, and DuckDB also works in WASM, so you can now actually use IBIS and Pyro and DuckDB in your browser, and it's weirdly performant, and it shouldn't be, but it is. So, don't know, it's kind of cool. Announcing IBIS ML, you can pre-process your data at any scale on any IBIS-supported backend. This is fully drop-in compatible in scikit-learn pipelines, but if you wanted to run it on some massive engine, you can do that, and it will just work. So please try it out, IBIS-ML. Here are all the places you can find us on the internet. Here are all the ways you can install BigQuery, ClickHouse, DAS, Data Fusion, Druid, DuckDB, Exasol, Flink, Impala, MySQL, MySQL, Oracle, Polars, Postgres, Python, Risewave, Snowflake, SQLite, and Trino. That gets harder every year. Come talk to us on Zulip. It's like Slack or like Discord, except there's good threading and your data isn't hostage to some VC. LinkedIn is a thing, and my colleague Philip Cloud has a live stream on YouTube that is fun. I think that's everything. Oh, and a huge shout out to the adult Patrick Clark, who made our awesome mascot.